लंच और व्हाट? अच्छा लंच नहीं खाने को मिला क्या? बड़ी धीमी आवाज आई। लंच में ही इंगेज है अभी तक। अच्छा अच्छा, तो जल्दी से आप लोग मोड में आ जाइए पढ़ाई के। ओके, क्योंकि okay, so we are going to learn something about today cloud, some of the basic cloud concept, okay, which we have not learned before, because I feel that if you don't know how cloud is working, if you don't know how Bluemix is working, this concept will be like irrelevant for you. Now you know how cloud is working, how you know how Bluemix is working. So I guess you need to understand these cloud concepts, which are very basic and which are very necessary for you to understand. Okay, like how cloud is working, how what is called hypervisor, what is called virtualization, what are the other concepts, and what are the other features involved in cloud. So basically, we will learn about those things. Okay, so let's start. So our first thing is we will learn about, our unit objective is to learn about how cloud computing leverages the internet, elasticity and scalability. You have heard the term elasticity and scalability, but I guess you don't know how elasticity and scalability is applicable. Okay, virtualization, what is virtualization and how we can achieve it. Another concept is the characteristic of virtualization environment, hypervisors, the different type of hypervisors. There are some different types of hypervisors which are being used in industry, in the industry. So what are the types of hypervisors? Provisioning and deprovisioning, multi-tenancy, what is multi-tenancy, and management in cloud computing, okay, including government tooling and automation. So we'll learn all these topics. So it will clear your concept, cloud concept, that these are how these things are running behind your Bluemix and how you are achieving that Bluemix thing on your system. Okay, so shall we start? Yeah, okay. So our first thing is cloud. If I'm telling about cloud, cloud is an internet. Okay, so those who can access cloud infrastructure over the internet, then it's called like a cloud infrastructure. Otherwise it could be like a shared pool of resources which is located somewhere. So it will be called as a data center, not as a cloud infrastructure. Okay, correct. So if I can't access those materials over the internet anywhere in the world, then it's not a cloud. Okay, so cloud is internet based computing, correct? Your concept should be clear that what is cloud. Cloud should be a internet based computing where shared resources, like morning we have discussed about that, we used to share our resources like software and information like data, any of the software and data provided to the computers or hardwares, okay, which can be accessed on demand anywhere from the world. Okay, like here they said like electricity grid. Okay, but I don't the better example you have learned by Bluemix, that Bluemix, how Bluemix you are accessing the over the internet, how you are accessing the data center applications, okay, services, and you can also understand how the information and data are being shared by you, okay, when you have done the DevOps thing. Okay, so everything is there. You have understood Bluemix, then you have understood cloud, but you don't know some of the features behind the cloud that are being implemented, and you might don't know that these are the features and these are the reasons behind the cloud. Okay, the cloud new consumption and delivery model inspired by consumer internet services. So actually, initially, typically, as normal consumer want to buy their own systems, okay, and they want to consume those services. They want to purchase the software they want to install on their system. But these days, like work, if you are working in a industry where you have a lot of things to do, then you can't do at your own system. Let's say tomorrow, today, and the today's era, some of the companies which are working on Linux, some of the companies which are working on Unix, and the company which is providing a solution to those platforms, they can't purchase so many systems, they can't purchase so many OS. So what they do, they purchase the cloud license, Bluemix kind of license, software license, and they used to work remotely on those systems. Correct? And they don't have to purchase those things, and they don't have to put in their premises, they don't have to provide electricity. Just you have to purchase internet services, and you can access those devices remotely from anywhere in the world. Okay, so here cloud enables self-service, okay, sourcing option, economies of scale, that we already have learned through Bluemix, that what are these options are. Now positioning cloud to a grid infrastructure. Okay, grid computing. See, it means as I said, your cloud infrastructure. Cloud is built with the several data source. Means several resource pooled. Okay, data sources where so many computers are placed in the form of grid. Okay, if you go to a data center of a cloud network, you will find that the racks of machines are placed over there, and they are somehow interconnected to each other. And the programs that are written to each other, they can share data and applications, and they are connected over the internet. So whenever you need those things, you can have those things on your laptop by connecting it. Okay, so the cloud, which has a grid like structure, when you go inside the data center, you find that the structure is like normally that grid infrastructure we see in a normal electricity grid. Similar kind of infrastructure we can see on the cloud data center. Okay, so here one example is that cloud computing is one vehicle that allows the cloud to scale up or down to meet the demand. Like, it should be elastic. Okay, so whenever a customer requires that, okay, I need more CPU, okay, I need more RAM memory, so cloud infrastructure should automatically provide those facilities to them. Otherwise, it lacks one of the major property of the cloud, that if it's not making the demand, okay, if I'm making the demand and you are not able to supply me, you are not a good cloud. Okay, up to a certain extent you are performing as a cloud, but you are not good cloud. Correct? Now cloud grid size varies from a super virtual computer composed on a many network loose coupled computers to a single task. Okay, to a small redundant dual computer system. Okay, so if I tell you that what the grid system should look like, it should be a super virtual computer, or it should be a grid of minces. If I tell you that three computers can form a cloud, yes, they can form a cloud. Okay, now elasticity in terms of rubber, in terms of, if I tell you the elasticity in terms of rubber. Okay, if I say that this rubber is elastic, this is not elastic. In terms of physics, what we call them elastic, when we can stretch them. Okay, and when I don't need to stretch them, it can go to it can shrink to up to a certain level. So a cloud should be such that it should automatically increase the size of, or it should automatically decrease the size according to the demand. Okay, if my demand is more, I should get more computing power. If my demand is less, I should get less computing power. Otherwise, and the charges should be like, if I'm using more, I should pay more. If I'm using less, I should pay less. So there should be a balance. Okay, so in terms of elasticity and scalability, when I need that, elasticity is the ability to expand or shrink a computing resource in a real time based on a user computer requirement. Correct? So it fits the definition. it should be have the ability to scale in terms of like when I want more computing power, I could get more computing power. If I need more RAM, I can get more RAM. If I need more space, I need can get more space. Okay, so if I don't get those features over cloud, that is not elastic, or that is not scalable also. Okay, sometime referring to a right sizing. Okay, if my appetite is more, I want more food to eat, and if somebody is not giving me that amount of food, I'm still hungry. Okay, so if your requirement is that, okay, I need more space, I need more memory, and then your requirement will be fulfilled, then cloud should provide that. Otherwise it should not be called as a scalable or elastic. Okay, the cloud service provider provides service based on usage. Okay, so if you are using let's say tomorrow, if you are going to purchase a cloud, there should be a price, okay, for cloud. So you need to choose according to your usage. Let's say tomorrow you have a service. Okay, service is like there is a particular set of data or cloud and data or any DB data is stored somewhere. Let's say you are the company which is showing the temperature at every time. Okay, you are changing the temperature according to what you are getting from the internet. Okay, or you are getting through your services. So let's say tomorrow you are showing those temperatures, and you are going to ask that, okay, I'm for this temperature I'm going to charge you. If you check my temperature service 10 times a day, I'll charge you this much. If you are going to check more than 100 times, I'm going to charge you this much. Okay, so if some services are or if going to use my memory or RAM up to this extent, I'm going to charge you for particular memory. Up to this extent, I'm going to charge up to this I'm going to charge more. So there it should be, if it's elastic, you will be charged according to your usage. And you need to, whenever you are going to opt a cloud, you need to first define what is my usage. Okay, do I need per hour plan, or do I need a per GB plan? Okay, correct. So let's say I want a push notification plan from Google. I want to purchase it. Anybody knows what is the push notification plan from Google? They allows a single company or users to purchase a license. Okay, once they are using 3 lakhs push notification per day, more than 3 lakhs push notification per day. If they are trying to send it, they need to purchase a license. Otherwise, Google will not allow them to send the push notification. Everybody knows what is push notification. Everybody knows about that. What is push notification? The notification generally you get on your mobile through the application is the push notification. Okay, so those notifications are coming through a company by a channel, proper channel called Google Android Google Cloud GCM channel, or a PNS channel, Apple Cloud. Okay, so they used to provide a rate over the channels that, okay, if you are use our cloud, and if you want to push this message to the particular device up to a certain extent, I'm going to charge this much. If you are using less than this, it's free for you. Okay, so Google is using their Google Cloud messaging services, that is called GCM, to send push notifications to the devices. So up to 3 lakh they are asking making you free. If you are sending 3 lakh push notification per day, it makes you free. But more than that, they will going to charge you. So the companies like Myntra.com, Flipkart.com, they have a customer base around more than 3 lakhs. So they used to push the notification beyond that 3 lakh measures. So they are being charged by GCM for the service they are using from Google Cloud. Correct? So if I say you uses the usage must meet service level agreements SLA while minimizing cost. As I told you that what are the plans you need to take, you need to define the plans first. Okay, tomorrow if you're purchasing any cloud network, just check the plan. Are they asking for per hour, per GB? Okay, so choose according to your plan. Whatever you need, choose according the plan and opt for it. Okay, otherwise what they will happen tomorrow, if you choose a plan for per GB RAM and you are asking for a hit rate, then there might be a conflict and they are going to charge you more. So better you should check your plan that I'm per hour I need this much of transaction to happen through that network. Correct? And yeah. So now you can see. Correct. They have to purchase license. No, I'm just talking about push notification. Push notifications are generally, yeah, notification you generally get it from when you are not, mobile is not on, or let's say you're logged. Okay, you see a pop-up coming up like if I see here is some of the messages are like, okay, these are push notifications. You can also see those notifications. These are notifications. So Myntra sent me a notification, enjoy 2000 rupees off. Okay, so enjoy 2000 rupees off is sent through Myntra. Okay, and these are push notification, and these are coming, this is the Windows device, so this is a coming from Windows server. Okay, so for Windows device, Microsoft has created their own Windows server where you can go and opt for that, and tomorrow if you want to have it, you can have it according to the rates. So the Myntra is going to pay to Microsoft for using this service for own Windows mobile. In that case, if you are using, then you can send up to 3 lakh messages, 3 lakh push notification messages per day. But if you are going beyond that, even though if you are using any of the services like if you trying to use the Google Map, and if you're trying to locate your service more than lakhs, means there are some certain criteria given on maps also. If you are trying to access map all the time and your users are that you have written a code, okay, tomorrow you will write a code and you will going to distribute your application. So every application will bind through a certain key, then key will try to access the location. So Google will know that how many users are trying to locate trying to access the location through my Gmail account or through Google Map account. So if they find out, okay, you are going beyond this limit, which is a chargeable limit, they are going to they are going to ask you that, okay, you have to purchase the license, or either you have to you are not able to send those informations to your customers. So these are the terms. They have made their cloud. That's why they are charging it. Okay. So tomorrow, if you are going to Amazon and you are trying to purchase a system, or you are trying to purchase any of the services, you have to pay for that, and you just have to check what is the requirement and why I need to pay this much. Okay. So elasticity and scalability are used to achieve this. Okay, to meet the demand. Okay, if demand is higher, they should provide higher. If the demand is higher, they need to provide the services up to a higher extent, like they want your CPU utilization. If CPU utilization is going high, they need to provide more CPU. If your memory, if your RAM, memory, any of the things is getting high, they need to provide those things. Okay. Example of when elasticity is valuable during the load testing. Anybody has done the load testing? load testing means, let's say there is a server. Okay, the server having 8 GB RAM, and it has a processor, octa-core processor, like your mobile. You can say, check on your mobile what is the maximum limit. You can open your apps on your mobile and run multiple apps on your mobile. You see these days in the market that, okay, you can this mobile has octa-core processor and 2 GB RAM. It means that it can handle up to a certain extent of applications. A mobile which has not octa-core, they have normal core, they can handle up to 2 3 apps. If octa-core can handle up to 10 or 15 apps, there are some 2 octa-cores or several means processors in the market, they can handle up to more apps. So they have a capability. Similarly, when you do the load testing in the servers, you can check the capability, that how much it can handle. Okay, so here in the left hand side, you can see that there is a simple simple diagram where two computers are connected to a CPU, and they are connected to a database. Okay, correct, left hand side. Now I want to scale my demand. Okay, I have more demand, I need to scale up my demand, then I need to provide more CPUs, more monitor, more systems, more databases. Okay, when my demand is down, I can go back to the normal situation. Okay, now virtualization. Those who have those who have read the virtualization can tell me what is virtualization in terms of layman. If I am a novice, I don't know anything about virtualization, how could I explain a virtualization? Can anybody tell me? Correct. So it's like a replica. Okay, virtualization is like replica. As let's say you have a system which is located somewhere, and I want to access the same system on my desktop. How could I access this? Okay, try to understand this point, that okay, in virtualization is a computer science term, where we try to see a replica of my computer which is located remotely. Okay, a system which is located remotely, I want to try that. I want to use that system on my desktop, on my laptop. How could I achieve this? I have to make the replica of it. Correct. So virtualization is like, I am virtualizing the same system, and I am using the same memory power because that system has. Once you virtualize those things, it means that you have the same system in front of you. Only and it's through its replica you can perform the same thing that you are performing on your own system. Clear? So I have means at the end of the session, I'm going to ask these questions also. There are some question answer, I'm going to ask those things. So please understand. Okay, this is very useful for you. Virtualization is just a concept. Okay, and which concept in this concept, what we do, we use to replicate a system which is remote placed remotely, and we want to access those things. Okay, correct. So here the definition tells us that virtualization involves a shift in thinking from physical to logical. Correct. That we treat like logical resources, like they are kept at a separate location, and we can use them at any location we want it. Okay. So with virtualization, you can consolidate following resources in your virtual environment. First, as processors, storage, and networks. Got it? So it can use following resources in the virtual environment. What is that? Processors. What the process will happen over the system, you can use it. Network. what the system has the network, you can use them. And what is the storage? You can use the storage which is remotely located through virtualization. Okay. So with virtualization, one physical resource can be made to look like multiple virtual resources. Correct? So with using the virtualization concept, we can make one physical resources to make it look like multiple virtual resources. Virtual resources can have same function, features that are not available on the underlying physical resources. Okay, got it? Everybody has clear on this? Now we will be see what are the things can be virtualized when we do a virtualization. Okay, when we try to virtualize a system, we can virtualize hardware, network, storage, operating system, applications, desktop, and data. So all things come into that, I guess. Nothing is left out of it. Okay. So the main advantage of virtualization in cloud computing is that software is decoupled from the hardware. Okay. Correctly. Both way it has it is decoupled from the hardware and the cloud, and you can use the same resource anywhere. Okay, decoupling allows hosting an individual application in an environment that is isolated from underlying operating system. Anybody having any issues? Okay, now you have understood what is virtualization and how, what are the things we can virtualize and what is the role in cloud computing. Now characteristic of virtualization can be done like partitioning, isolation, and encapsulations. So can anybody tell me any simple example about partitioning? What is partitioning? Those who have learned virtualization can tell me what is partitioning, how we can achieve this. So you might have seen that in your computer system, somebody wants to try Linux, they can install Linux, they can install Windows. Correct? They have seen this feature, I guess. So this is the kind of partitioning. Okay, they can install multiple applications, multiple OS operating system on the single physical machine. That is called partitioning. Sorry, ma'am. This is a characteristic of virtualization. Using VMware, in your normal system, you can install Linux also. You can install Windows also. Correct? Now, isolation. What is the meaning of isolation in virtualization? Correct. So both, if I am trying, if there are virtual machines are completely isolated from the host, okay, other virtual machines. So if I'm telling you that I'm using this virtual machine and I'm using those virtual machine, so both machines are segregated, separate. Okay, those are isolated. I can't. Okay, if I'm doing changes over one virtual machine, that doesn't reflect the changes over other virtual machine. So it's totally isolated. Encapsulation. Encapsulation means what? Mm-hmm. Mm-hmm. Anybody else wants to put their thought on encapsulation? What is encapsulation in terms of virtualization? Those who have learned virtualization, they should have known the terms. Okay, encapsulation is nothing but the entire state of a virtual machine is in hardware independent files. Okay, meaning now you have no entire. Uh-huh. Mhm. 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 So there's see, if I have two states, okay, of a virtual machine, okay, so there should be no interference between them, correct? There should be no interference between the states of the virtual machine. This is called the encapsulation of a virtual machine. Now benefit. So we have created virtualization. So means there should be meaning that we need something out of it. That's why we have created it. Okay. So why we created it? To consolidation, to reduce the hardware cost. Okay. Hardware cost. Okay. Enables you to have a single server function as a multiple virtual servers. Okay. You can run multiple application over one server, and but you can access it from the different resources to run the applications. Okay, so it looked like a multiple virtual servers. Optimization of workload can increase the use of existing resources by enabling dynamic sharing of resource pooling. If you are using resource pooling, you can optimize the workload over there. Okay. Now IT flexibility and responsiveness enables you to have a single consolidated view of easy access to all available resources in the network regarding of location. So once you are at a different location, you want to check your all the files which are located on your system, you can see that, correct? Now you have virtualization is giving you one flexibility that whatever the system that has been kept in the data center, cloud data center, can be, you can see those things, you can have a partitioning over there, you can put some files over there, you can run multiple applications. Okay, you can install any of the OS, you can install any of the software over there. Now after using our virtualization, we have not stopped yet. Okay, because we have dealt with some other problems like why after virtualization, why we need a hypervisor. Sorry. Mm-hmm. No, my simple question is, if I have a if I have achieved virtualization, why do I have a hmm. Mhm. Hmm. Hypervisors. Okay, anybody else who knows hypervisor? What is hypervisor? Okay, those who know that should try to understand why we need a hypervisor after that. Okay, now virtualization in cloud computing, how it's going to reduce your cost. Okay, like virtualization is like, if I'm doing a virtualization, I'm a energy efficiency standardization is coming up, automation I can do, and I can reduce the cost. Okay, once I've achieved achieve this, I have another things in my hand like agility, business and IT alignment, say service flexibility, industry standard, and I can optimize the business also. Okay, now hypervisors. Anybody who has understood the hypervisor can explain, they can take part in the discussion. Hmm. So if I'm asking you, how is it different from the virtualization? Okay. Okay. Is it a software or hardware? Okay. Okay. So those who don't know, they need to understand that virtualization software that allows multiple operating systems to run on the same computer concurrently. Okay. Those behaves. Those are like hypervisors. Now I have some definitions written for the hypervisors. Okay. So just read this definition. It's a very simple and basic definition for a hypervisor. Okay. Hypervisor is like a hypervisor or virtual machine monitor is a piece of computer software, firm or hardware that creates or runs virtual machines. Correct? It's nothing but a piece of hardware, software, firmware that allows to run virtual machine, that runs the virtual machines. Okay. So a hypervisor is also called a virtual machine manager. Okay. If you have a virtual machine on one system, it could called as a VMM. Okay. Virtual machine manager. It's a program that allows multiple operating systems to share single hardware. Okay. To put multiple operating system on a single hardware. Okay. How you achieve that? I can have more than one OS on my system host. You can achieve using our hypervisor. Okay. So each operating system appears to be a host processor, memory and other resources to itself. Okay. Got it? Okay. So now if I tell you that virtualization hypervisor is a virtual machine manager. It's like senior most. Okay. If I'm doing a virtualization, it's a senior most who can handle the virtual machines. So when he handles the virtual machines, that it should not allow them to conflict between together. Okay. So two hosts, two guest operating system. If there are two guest operating system on one host machine, they should not. Okay, what they should not collapse together. So that means there should not be a collision between them. Okay. Okay. In the industry, we have two kinds of hypervisors. Okay. First name is native or bare metal hypervisors. Okay. These are those just names. Okay. Industry uses the hypervisor in only one way, but these are the some names. Okay. If you try to find the difference between them, there is a very minimal difference between the hypervisors. Okay. But we call them a type 1, okay, and type 2 hypervisor. First is native or bare metal hypervisors. Okay. That runs directly on the host hardware. The basic common difference is that runs directly on the host hypervisors. Okay. Host hardware. Okay. To control the hardware and the manage the guest operating system over it. If I show you, this is the, so if you see a host physical hardware is there, on top of it there is a hypervisor. Okay. On top of it you can see that para virtualization drivers and tools are there, where you can have multiple VMs of Windows, Linux. Okay. So When you have a hypervisor which directly runs on top of your host hardware, it's called a type 1 native bare metal hypervisor. Okay. Now it also manages the same thing, means it also manages the virtual machines, but it's directly on the top of host physical hardware. Sorry, para virtualization drivers. I need to find that. I'll give you explanation about that. Okay. Now there are the second type which is called hosted hypervisors. These hypervisors runs on a conventional operating system, not on the host. Okay. So let's say if you have, just write down the difference is that runs on the same hardware, host hardware. It runs on the conventional operating system. On the top of once you have this picture will showcase you that once you have a host physical hardware, you have a physical software over there. Okay, host operating system. Let's say host have an operating system. On top of that, you are putting your hypervisor, and that hypervisor is trying to give you flexibility to create multiple VMs on top of it. Then it's called a type 2. It's not a type 1. So there are that is like a very small difference between type 1 and type 2, but industry defines it like that. There are two types of hypervisors, type 1 and type 2. First is bare metal, okay, and second is hosted hypervisors. Correct? Hmm. 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 Type 2. Hmm. डायरेक्टली आप वर्चुअल जो आपके हाइपरवाइजर्स है डायरेक्ट आपके ऑपरेटिंग सिस्टम के बिना होस्ट के जो मशीन है उस पर आप डायरेक्ट डालो, उसके ऊपर आप वीएम क्रिएट करो तो आपकी बन जाती है। ये पिक्चर देख लो आप। हाँ, विदाउट ऑपरेटिंग सिस्टम। हाँ, करेक्ट करेक्ट करेक्ट। हाँ, both fashions. That's why it have a difference, type 1, type 2. That's why first one is called bare metal and second one is called hosted. Might have both the. They have used the both kind of. Which one? Hyper-V. Yeah, actually most of the hypervisors which are designed like for Windows, Linux. So if I tell you that there is a small difference between hypervisors and virtual machine is like hypervisor is the device or software which runs the virtual machine. It's like manager. Okay. Virtual machine is like working under the hypervisors. Got it? So everybody is clear on this page that what is hypervisor, what is virtual machine, what is the type of hypervisor, why we need that thing. To create multiple VMs, we need hypervisors. To manage those VMs, we need hypervisors. Correct? So this is the basic difference between them. Uh-huh. Mm-hmm. 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 Your machine is hang, but the virtual machine is running. Some of the process might you are not able to see on your desktop machine, but and beyond behind that process, some of the process are running. So if unless and until you shut down your machine, virtual machine might be running. In both. if I'm running those things, they are utilizing the both of your resources. आपने अलॉट कर दिया ना, तो आपने आपकी वो रैम सिस्टम की ही रैम होगी ना, वो तो कहीं और से लाते हैं. वो एक्चुअली में आपने जो पार्टीशनिंग की 2 GB 4 GB रैम पर, आपने उनको डिफाइन किया 5 टाइम्स में. पहले तो 4/5 हो गई, ठीक है. उसके बाद इंटरनली अब वो 2 GB रैम चाहिए, तो उसको 2 GB रैम तक एक्सटेंड हो सकती है, लेकिन उसको मिल कितनी रही है? 0.4 GB रैम आई गेस, ठीक है. वो 0.4 GB में ट्राई करता है रन करने की. अगर वो रन करता है तो रन करेंगे, अदरवाइज सिस्टम हैंग होगा आपका. उसके लिए तो मैक्स मेमोरी 4.45 GB ही एलोकेट हो गई है. आपने डिवाइड कर दिया 5 VMs में, तो उसके लिए तो कुछ एक चौथा एक जो 1/5 पार्ट है रैम, उसको एलोकेट हो गई. अब वो उसमें रन कर पाता है या नहीं, उसकी टोटल कैपेसिटी 2 GB तक, आपने 2 GB है फाइनल कैपेसिटी, आपने डिफाइन की कि ये 2 GB तक मैक्स लेगा. ओके, यही सिस्टम बात है. ओके, so everybody is clear about what is virtualization, what is hypervisor. Okay, here in the picture also you can see that the two different kind of they have decided to tell us that there are two types of hypervisors. First is this native and bare metal, where SMP server is located. On top of that we have a hypervisor. Another is on top of SMP server there is another operating system, and on top of it we are putting a hypervisor, and then it's called hosted hypervisors. Correct? So both hypervisors are clear. Okay. Now provisioning and deprovisioning. What is provisioning and deprovisioning? Correct. Okay, when you try to access some of the piece of software or hardware, okay, but you are not able to use it, it means you don't have a provision to access those things. Okay, correct. So cloud should have a kind of concept, should have a concept of provisioning and deprovisioning, because today you need those things, tomorrow you don't need those things. Okay, correct. So a provisioning system controls applications available to users. Okay, a provisioning system will only control the number of number of users which can use the number of software, hardware, what he has been provisioned till now. Let's say you are running a Blue Mix. Okay, everybody runs a Blue Mix. They see that once your memory limit has exceeded to more than 2 GB, you are not able to run your application. Correct? So Bluemix has provisioned you only 2 GB of RAM, on which you can run up to multiple, means how many number of applications depend upon you. Okay, deprovisioning provides resource reduction of users and softwares while delocating backend resources like hardware and softwares. So once you find that I don't need this software, I don't need this hardware, so there should be a deprovisioning kind of concept should be there, so that they will take it from you, and they will not going to charge it for you. Okay, so if I'm not utilizing some of the resources which is given to me, and I don't want to pay the charges for it. So there should be concept like, once I reduce the in the scalability, I should not, it should be deprovisioned from my account. Okay, self-service provisioning allow customers to request the amount of computer service. So there is a self-service provisioning in cloud computing, because once you go for elasticity or scalability, once you talk about those elasticity and scalability, you need at a certain time you need to have a provision to access the cloud computing, storage, process, other resources, and sometimes you don't need that. Okay, so for that there is a deprovisioning also. So self-service will give you resources like computing power, storage, software, process, and other resources. Okay, and due to provisioning and deprovisioning, it's like eliminates time delay. Okay, if I need that, I can get it. Okay, tomorrow you are going to charge me more, but I can get it. But if I don't want it, I can leave it also, and I don't they will not going to charge me for that. Okay, now multi-tenancy. What is multi-tenancy? Can anybody who wants to explain? Yesterday, I guess somebody was telling about multi-tenancy. Morning also I have heard multi-tenancy. What is multi-tenancy? Hmm. 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 Correct. Okay. Everybody has listened, Aditya. Anybody who has listened, Aditya? See, anybody who is taking part in the discussion, you should also listen them also, because they are taking part in the discussion. If you want to take part in the discussion, take part. Otherwise, if you want to talk about something else, you can go out, no problem. Okay, already your organization paying so much money to IBM. Okay, we don't bother about those things. So whenever somebody is taking part into discussion, listen carefully. Okay, so anybody who have heard Aditya? Nobody. I guess everybody is getting busy into something else. Okay, so what is multi-tenancy? Anybody? Break the words and try to understand what is multi-tenant. Correct? Multiple users that are going to share the resource. Correct. Via virtual machine. So if somebody, let's say I have a farmland, as Aditya said, I have a farmland, I'm making a building over there, and I'm giving a building, every apartment to rent to somebody else. Okay, this is the in the layman terms when I'm trying to understand the multi-tenancy. So anybody can come and share the apartment, they can leave the apartment. Okay, so once you have a piece of software or hardware, if I don't have multi-tenancy, then what will happen? Tomorrow my cloud infrastructure will be like useless. If one system is being used and one system is not being used, then what will happen? Underutilizations. We will not utilize the whole resource power, whole resources, whole the efficiency will go down. Okay, so we need to have a multi-tenancy on our cloud. Okay, so that each customer can have their own resources, but they can't share the means there is no such issue between those resources and the customer. Okay, let's say tomorrow I am purchasing a cloud, you also purchasing a cloud on Amazon or IBM. You having your own account, you are putting some data over there. Let's say Dropbox is based on a cloud storage. So everybody is are keeping their own data over Dropbox. So once you want to find your own data, you can go and find your own data. But whenever I'm trying to find your data, I can't find that. Okay, because I don't own that data. So in multi-tenancy, what happens that whenever the resources had been shared to among the customers, that will be a segregated from other customers. Okay, that cannot be used by other customers. Correct? If that is being used, it's like if I want to share, I can share, but there should be like that. Somebody cannot access my resource. Okay, if I'm trying to use my resource, nobody can access my resource over the cloud. Then it calls a multi-tenant. The form of multi-tenancy is relatively inefficient. Okay, so for that, fine-grained multi-tenancy has been introduced. All resources are shared, but the customer data and access capabilities are segregated with the applications. Okay, multi-tenancy is like, okay, I have some users have came and acquired the 3 BHK flat. Some users have came and acquired the 1 BHK flat, but they are not utilizing those area. So what we'll do that, we'll have a fine-grained multi-tenancy. Okay, once you are in the morning, I will give you this part of your as part of the room. You will go and sit there or sleep there. Rest of the room I'll occupy with some other users. So fine-grained multi-tenancy are like shared, but only the thing is here everything will be shared. Only the data will be segregated. Okay, the data part which is not going to conflict between the two multi-tenants. Okay, the form of multi-tenancy is much more efficient, offering superior economies to scale. If I having a fine-grained multi-tenancy, I can give a better offerings over the cloud. Okay, because I'm utilizing most of the resources, most of the cloud computing power, and I can distribute it to many of the customers. Correct? Fine multi-grain. Simple is like let's say tomorrow you have a system, ma'am. Okay, and tomorrow you have a system. You want to access through a virtual machine. Okay, you can access the same data. Okay, but you can form there is a such a some of the things like whenever you are generating some of your data, it is going to store at some place where other person which is coming to the same place. Let's say two users are sharing the same system, but they can't see each other files. Only the fine grained multi-tenancy allows them to not to share the data. Like if you can see the Dropbox, or those are already having the software which is running on the cloud, but the data which you put keeps anywhere, you are segregated from the other customers. You can't see others data, and nobody others can see your data. So only data part is segregated, rest of the things are like same kernel, same OS, same software, everything is same. Only the data part is segregated over there. Yeah, same virtual machine also. In I told you that multi-tenancy, like if I occupy a normal building, or I occupy a simple flat, and that is a 3 BHK flat, 3 rooms are there. I'm occupying only, I can sleep only one room at a time. 2 rooms are vacant. So like 2 rooms are waste. Okay, but in the fine-grained multi-tenancy, what happens that okay, when I require this room, I can have this room, I can go and sleep. But the 2 rooms which are unutilized, I can share with other people. Fine multi. So platform as a service model of multi tenancy. Platform as a service model is like where you share your platform, runtime, everything, but you don't share the software piece, application, data. Okay, that is the only part which is left. So whatever the application and data you maintain on the platform, it's like you are a tenant for the platform, and nobody is going to see your data unless and until you want it to share it with them. Okay, like the Bluemix account. Bluemix is a pass. Once you create an account over there, you will have your own data segregated from the others. You can't see others application in your account, and nobody can see your application in their account. Each customer is isolated from each other. That is the main part of it. That data and application should be segregated from each customer. Correct? Clear? Any questions? SaaS and no, ma'am. The multi-tenancy here is platform as a service model of multi-tenancy. Platform as a service model is like it's already a model where you apply the multi-tenancy to segregate the users. Each customer should have their account and they can see their own data only. Or they can keep their application on the same cloud, but nobody can else find it. Let's say tomorrow, yesterday you have created an account on Bluemix. Everybody, 30 people in the class have created account on Bluemix, and the same the cloud is the cloud data center is located in Australia. Maybe you are using the same system, same host. Okay, same host, same virtual machine. Maybe 30 people are using the same thing, but their data is segregated from each other. So that is the case where of platform as a service model of multi-tenancy. Here is one picture in multi-tenancy. Types of tenancy is like this is a simple multi-tenancy, like multiple clients are there and they are trying to access this one VMs. Let's say the upper computer is like one VM, and if number of system, according to the number of system we are defining for a particular, let's say I said you that one flat, I can share one flat. One person can buy one flat, but one flat can contain several rooms also, like 4 rooms, 5 rooms. Here you can see that if it's a part of DB, you can say that every system will store different DB for different client. But here in the fine grained multi-tenancy, I have a single DB, but having a layer. First layer and the bottom layer is for client 1, second layer is for client 2, third layer is for client 3, fourth layer is for client 4. So this way they are separating the data, but having a single database. So they are utilizing the resources. Sorry. Client, if yeah, let's say if you want to have a tomorrow, if you want a complete system, you want to purchase a cloud where you want a complete system, 50 GB storage, 5 GB RAM or 2 GB RAM. Okay, says with OS, Linux OS 64-bit, you can use that system also, no problem. But when you, as I said, you in the multi-tenancy in platform as a service, and you see the multi-tenancy here, it's like you can everybody, 30 people in the class have the same account on Bluemix, but they shared, but and the same data center also. They might be using the same VM also, but the thing is they are segregated from each other. Nobody can see his data on their machines or their account, and nobody can see their data in their account. So it's segregated. That is the called fine grained multi-tenancy. Okay, clear? Now, application programming interfaces. What is application programming interfaces? APIs. Anybody? What is programming interface? Application programming interface. In the layman perspective? Mm-hmm. Mm-hmm. Set of protocols to? Okay. Anybody? Yeah, means most of the part of your correct. Anybody who wants to programming interface? Programming interface means application programming interface. It's a it's a way to you can achieve the communication between programs. Okay, it's nothing but it's a way. Okay, it's a way through which you can have a application program, you can achieve you can access those programs through a particular interface. Let's say I want to communicate, okay, between two data sources. I have a program written. I want to write a program that, okay, this program will going to connect to my DB. Once I'll write this program, it will going to fetch the DB data and take it back to me. So that is a called API. Okay, they try to communicate between two programs. Okay, one which is written in the database, one written in web, but that try to communicate between two programs through a interface. That is called a application programming interface. Correct? Understood? Okay. Now, if you see, cloud services have a standardized application programming interface. Why we need a standardized application APIs? APIs. Let's say tomorrow, if I want to connect to a DB, I want to connect my application to a DB. So I don't have to go and write all those fuzzy programs, okay? Because if I have APIs available, I just have to call a particular API or just call a particular function, pass the particular value, you'll get the result back. Because that API is already a program which is written to communicate between two different kinds or two same kinds of the program. Okay, that is the interface. Okay, so the interface defines how two or more application and data sources can communicate through each other. That is the more important part of the API. So multiple application communication, there are APIs which can communicate through multiple applications. Okay, and they can bring this data. There are multiple data resources through which you can communicate and you bring the data and utilize. You can use the data in your application. So there are different kinds of APIs can be formed for different applications for different data sources. So why we need an API? API gives you a flexibility, or is means it's very easy to use the APIs. You don't have to worry, okay, how I need to connect. Okay, tomorrow if you need to connect to a cloud service, you need anybody who has done the Java, have written a Java program and tried to connect to MySQL DB, they need a jar file. Correct? They need a jar connector. Why do you need a jar connector? To connect between it can communicate between two systems. Okay, so here when APIs is written, they already have jar file installed over there. What they'll do, they will give you an interface. Okay, you can use this API to communicate between the data source easily. So it allows a customer or infrastructure to use the services or use the application, use the data sources easily. Okay, cloud API has not been standard. See, soon you can see that the market will grow, API market will grow more, because everybody wants to have, let's say, today in the market, if I want to grow, I have to be fast. I don't want to, let's say, today I don't want to invest much time on algorithms which are already available in the market. Let's say standard algorithms are like encryption algorithm. Okay, let's say tomorrow you want to encrypt your packet and want to send to somebody else. Okay, before decrypting it, so that nobody should come in between you and the system, and they can decrypt it. So, but the algorithm is so complex that you can write it, but it will take some time for you, like month, even if a month, even if a month or 2 months, it will take some time for you, and your project is going to be a halt for them. Okay, for a particular time. So what will happen? I have a plug. Okay, I have a plug kind of thing, which I tell that, okay, pass through this API. The data which comes out of this API will like encrypted, and whenever the other end of the customer which is using your other end of the plug, they can decrypt the data. It's like magic, but magic is means this magic can happens only when you pay for it. Okay, some of the APIs which are disclosed right now, like if you go to an OpenStack API or CloudEnt API, those are like open source APIs are available in the market. You can use it directly. But if you are trying to get something, if you're trying to achieve something more important, and which are owned by some of the companies like IBM and other companies which are developing APIs so that they can provide ease ability to develop something to their customers, they will going to charge it. Okay, let's say you are going, somebody is providing a pipeline through which you can measure. Okay, you can go and you can pass your big data, and they will give you analysis. So there is an API market coming into the near future for cloud, where you will see that you just have to plug those APIs in your application and you will get the result. Correct? So there are API already written in Bluemix, through which you can directly connect to your Cloud and DB, MySQL DB, RabbitMQ, any of this. Okay, just you have to provide certain small credentials, like how you need to pass the data, and what are the credentials you need to pass, like a application ID, username, password. That's it. And use the API, and you are ready to build the application. So it like it turns out to be like a magic. But the thing is, already you have an interface through which you are getting the result. Correct? Billing and metering of services. I guess everybody understand how billings are being provided. Okay. Economies of a scale. Everybody understand that if I need more, I need to expand more. So I'm not going to talk about those things. Okay. So let's have a tea break. Okay. After tea break, we'll come up and we'll understand the management, tooling, and automation in cloud computing. Okay. Okay. Let's go for a tea break. We'll come.